Let's look at this one. This is a problem from your Math Excel homework. Okay? So this one, we're not relating this piecewise defined function to anything that we, I've got the screenshot to give to you. So you don't. Now, this particular function has 3 layers to it. Okay? Let's look at it one at a time here. Before we even start trying to do what the problem is telling us to do, let's look at it. This says that when I'm considering the function named h, I'm going to use this top rule under the condition that x is less than negative 7. So I only get to use the top rule when x is less than negative 7. I can use the middle rule. This condition, this function says h of x equals 3. The outputs will be 3 when x is greater than or equal to negative 7. Look at how I'm reading that. X is greater than or equal to negative 7 and less than 3. And x plus 4 is our bottom rule, and we get to use that rule when the x values that we pick and utilize are greater than or equal to 3. So this is a piecewise defined function. So they ask us to find h evaluated at negative 10. Tell you what, let's do it this way. Top rule, middle rule, bottom rule. All right. So the top rule is h evaluated. I'm going to write the empty function here. When h is empty for the top rule, it looks like this. When h is empty for the middle rule, it looks like this. And when h is empty for the bottom rule, it looks like this. So with a 4 there, not an x. Okay. Now let's look at our conditions again. All right. So with those conditions, which rule do we get to use if we want to take h and evaluate it at negative 10? The top rule. Okay, Christina's right. Negative 10, that number is what needs to go in, and that fits this condition. Negative 10 is less than negative 7. So if I want to evaluate h at negative 10, I'm going to plunk it into the top rule. It goes into my empty function, but only into the top rule. You don't use the other ones in this case. So h evaluated at negative 10 is equal to 28. Did we all get the same thing? Negative 4 times negative 10 is positive 40 minus 12, 28. Okay, and that's the only one you use. You don't use the middle one, you don't use the bottom one to do h evaluated at 10. So that's the first one that they'll probably want you to input into the Math Excel. Okay, that's the first one. So that's this one. Okay, Tanisha, did you have a question? Okay. Negative 6. H evaluated at negative 6. H evaluated at negative 6. Which rule? It goes to the second one, doesn't it? Okay, think money. Negative 6 is greater than negative 7. Okay, or actually temperature helps here. Give you some intuition. 6 degrees below 0 is warmer than 7 degrees below 0. So it fits in right here. It fits into this one. So when we wrote this empty, it looks like this. This middle rule says h evaluated at x equals 3. So no matter what value goes in for x, what comes out of the function is going to be 3. All right? So I'll do this one. I wish I had a lot more different kinds of highlighters, but I don't. So, all right. Now about 3, where does it go? H evaluated at 3. Okay, this goes to the third one, because in the third one is used when x is greater than or equal to 3. All right, and so if we plug that in there into our empty function, 7 is our output. Input, output for functions. That's the mathematics of it. H evaluated at 3 is equal to 7. If n goes 3 into this piecewise function, we plunk down here to the third rule, and we compute it, and we get 7. At the very end, we've got 8. This one here, it's supposed to be a 3. For some reason, I'm trailing on here, and I'm not making very clear numbers. So that's supposed to be a 3. So I did it again. All right. Now, because we look at it like this, we can graph this. Do you guys have any graph paper today? Okay. You'll want some graph paper for your graphs that you're going to do for me this weekend, okay? So be sure to have some graph paper for me. I'm going to skip this one. I'm running out of time here. I want to go to this one. I'm going to go to this one. This is the one I'm going to go to. So, I'm not going to get to the back page of this today. I'll have to wait till Tuesday to get to there. All right. Let's look at this one. Let's go through how we would look at the graph of this one. So this is, again, I know it's kind of hard when we go back into just these old plain old mathematical ones. This is a mathematical piecewise defined function. It's not on your handout because it's just an example that I want to do. And if you guys had some graph paper or something, just have to take notes on your own notebook paper. Something here. Let me see if I can show you what I've done here. Is this function is the function evaluated at x is, okay, we've got two rules here. It's a two-layer one here. You're going to use this rule, 2x plus 3, when your x values are greater than or equal to -1. And the bottom rule is going to be f of x is going to equal to x to 7 when your x values are less than -1. All right. So the way to graph it, we're going to graph it. The hint that you want, this is what our instructions are, to graph this piecewise defined function. If you want to graph this, then what you're going to do is look at it as two separate rules. In the top rule, we're going to pick some numbers for x. When you were doing graphing before, you pick numbers for x that you want. Well, let's pick some numbers for x. But you guys have to tell me which ones. 0, all right. 1, 2, okay, let's go to 5, and maybe we go to 10. Okay. What about -1? Does it go with the top rule? Do we use -1 at the top rule? Yes, we do, don't we? Because this says x is greater than or equal to -1. So let's put another couple numbers in here. -1, what's a number between 0 and -1? -0.5. Let's use that one too. All right? So what this is saying then is I'm going to evaluate this function for 1, for -1, for -1/2, for 0, for 1, for 2, for 5. So I'm just writing this empty. This is the empty function, and for 10. So when this is empty, I'm going to put in -1. I'm going to put in -0.5, or half. I'm going to put in 0. I'm going to put in 1. I'm going to put in 2. I'm going to put in 5. And I'm going to put in 10. And that's going to generate me some ordered pairs. So when x is -1, the output turns out to be +1. When x is -1/2, the output turns out to be +2. When it's 0, we get 3. When it's 1, we get 5. When it's 2, we get 7. 5, we get 13. And 10. Do you all know where I'm getting these numbers? Just doing those computations here. We get 23. Okay? So do you guys know how to graph these on graph paper? So you're going to have to draw a grid, and you have to label your scale. I'll show you what the picture looks like at the very end. Okay, thank you. All right, I'm so glad to have extra eyeballs on my work. Thank you, Tanisha. Okay. Yeah, because otherwise these wouldn't line up so good. So if I plugged in a -1/2, 2 times a -1/2 is -1. And then -1 plus 3 is +2. That's where I got that. But I did have the wrong x value there. The endpoint there was negative 0.5. All right. All right, I know I've got 2 minutes. Tell me some x values that I can use over here on the bottom rule. Can't use the same ones, can I? Because when I use the bottom rule, I have to use numbers that are less than negative 1. So Scooter suggested negative 2. Okay. That's a number that's less than negative 1. What else? Negative 3. So you guys have all named me some really good integers that are less than negative 1. Tell me a number between negative 1 and negative 2. Something that's close to negative 1, but less than that. Negative 1.1. That's less than negative 1. Owing somebody $1.10 is worse than owing them $1, right? Tell me one more. 1.7. Okay? So, in fact, I could even do this. Isn't this number still close to, very close to negative 1, but still less than negative 1? Negative 1/1000th. We're starting to see some of the kind of calculus things that we're going to be doing. What we're doing here is we're getting numbers that are close to negative 1, but just ever so slightly less than that. All right? The calculations are easy, though, because look at what this function says. This function says, if x is this, that f of x equals 7. In the way this function is defined, there is no place for x here. It just says it's 7. This part is a constant function. All right? So what are these ordered pairs? Negative 1 and 1/1000th, comma what? 7. Negative 1.7, comma what? 7. Negative 2, comma 7. Negative 3, comma 7. Negative 5, comma 7. So, when you graph that part of it, it's going to be a straight line. Okay, I know we didn't have time to graph it together. That's what my goal was. But the graph ends up looking like this. Okay, the top rule here is shown in red. If you plot it on your graph paper, get some graph paper, you have to mark it off. You have to mark this off in integers, equally spaced. The bottom rule turns out to be this straight line, a constant function.